Let's see the 12th question. See ma, 12th question is very easy. So just based on the formula. See here in the 12th question, what will be the ratio of the wavelengths of first line to that of second line of fashion series. Okay, it's very clear. Fashion series. Fashion series means Lyman series, Bomber series, next fashion series. Here for Lyman series N1 is equals to 1 and Bomber series N1 is equals to 2 and fashion series N1 is equal to 3. Okay, it is very clear. Lyman series for hydrogen spectral lines. Okay, lower energy level is always fixed. For Lyman series N1 is equals to N1 is equals to 3, it is fixed ma. So you have to keep it in your mind. What is the first line? In fashion series, first line N2 is equals to 4, 2, N1 is equals to 3. Okay, next second line N2 is equals to 5. Okay, and N1 is equals to 3. Okay, now it's a wavelength we have to calculate. First line wavelength, let it be lambda 1 and second line wavelength, let it be lambda 2. So just to imagine that we know the formula of wavelength. See, for this case, the formula is equals to, okay, what is the formula? See, 1 by lambda 1 is equals to RH or R into 1 by N1 square. 1 by N1 square value is 1 by 3 square. 1 by 3 square. N1 square minus 1 by N2 square. N2 square value is 4. 4 whole square into Z square. Into Z square. Here hydrogen atom Z square value is 1 only. Okay, that's why no means 1 square value 1 only. No need to write that. So you have to simplify that this 1 by lambda 1 is equals to R into 1 by 9 minus 1 by 16. Okay, the LCM is 9 into 16. Then 1 by lambda 1 is equals to R into 16 minus 9 by 9 into 16. Okay, it is very clear. Now just you simplify this. 1 by lambda 1 is equals to R into 16 minus 9 value is how much ma? 7. That is 7 by 9 into 16 is nothing but 144. Okay, see from this lambda 1 is equals to 144 by 7R. Okay, let it be 1. Next, second, the same way 1 by lambda 2 you have to calculate. 1 by lambda 2 value is equals to R into 1 by N1 square means 1 by 9 minus 1 by N2 square means 5 whole square is 25. Okay, now the LCM is 9 into 25, then 1 by lambda 2 is equals to R into 25 minus 9 by 9 into 25. Okay, then 1 by lambda 2 is equals to 25 minus 9 is equals to 16R. 16R into 9 into 25 value is 225. 225, then lambda 2 is equals to 225 by 16R. Okay, it is very clear. This is second equation. Now what they are asked, what is the wavelength ratios of first line and second line? Means lambda 1 by lambda 2 value we need to find out. Lambda 1 by lambda 2 is equals to lambda 1 value, how much they gave me? 144 by 7r whole by 225 by 16 is nothing but 16r into 225. See this 9 14 means 16 times it will cancel, then it is 9 25 times it will cancel. This r and r value will cancel. Next lambda 1 by lambda 2 is nothing but lambda 1 is to lambda 2 is the ratio of the first line wavelength is to second line wavelength is equals to 16 into 16 is equal to 16 16 ja is equal to 256. 256 by 7 into 25 value is 175. So therefore lambda 1 is lambda 2 is equals to 256 is 175. Okay dear students, it is very clear. Anybody have doubt? Let inform to me now. So here main important formula is equals to 1 by lambda is equals to RH or R into 1 by N1 square minus 1 by N2 square for hydrogen atom. That is the formula. Now here main important thing is Fasson series. Fasson series N1 lower energy level is 3 and higher energy levels are 4, 5, 6, 7 like that it is present. First line means the transitions between 4 to 3. Second line means the transition between 5 to 3. So the first line wavelength ratio, wavelength and second line wavelength ratio we need to find out. First line wavelength let it be lambda 1, second line wavelength let it be lambda 2. Lambda 1 is lambda 2 we need to calculate. Then lambda 1 is lambda 2 is equal to 256 is to 175. Means first answer is correct. Okay students, clear? Anybody have doubt? Inform me. Afjal, Amrita. Okay. Shravana. Shravana. Clear ma? Shravana is present. Saujanya clear. Shravana. Okay. Do hard work ma. Everyone must have to read more and more times. Practice. Then only the concepts becomes very easy. And do more applications also from different books. Okay students. Let's go for next question. It's very easy ma. 13th question. For the transition n is equal to 2 to 1, which of the following produce shortest wavelength? Shortest wavelength means lambda is low. So for this we have formula means n is equal to 2 to 1 means transitions whatever it may be 2 to 1 or 3 to 2 or whatever it may be in the transitions which produce shortest wavelength. So we have one formula for hydrogen like species. 1 by lambda is equals to r into 1 by n1 square minus 1 by n2 square. 1 by n1 square minus 1 by n2 square into z square. It is very clear here. R comma n1 comma n2 are constants. Okay, Z is atomic number of atoms or ions. See deuterium D. What is D? D is nothing but hydrogen isotope. H12. Atomic number is 1, mass is 2. Hydrogen atom means H11. Helium Z is equals to 2. Lithium Z is equals to 3. Lithium ion Z is equal to 3. See in this case 1 by lambda 1 by lambda is directly proportional to z square. Then lambda is inversely proportional to 1 by z square. Means what is that meaning? If lambda value decreases, then Z value increases. So which having more Z value, it has lower wavelength. So the answer is Li plus 2. So according to the options, lithium plus 2, Z is equals to 3. Then remaining all, therefore lithium plus 2 ion has shorter or shortest wavelength. See here, no need to calculate its wavelength also. Just we have to observe that different atoms or different ions they gave. Then 1 by lambda is equal to RH into 1 by N1 square minus 1 by N2 square into Z square. N1, N2, comma, R values are constant. Then 1 by lambda is directly proportional to atomic number whole square. But lambda is inversely proportional to Z square. Means Z value is increases, then the wavelength will be decreases. Wavelength will be decreases. So according that which having more atomic number, Li2 plus ion. That's why Li2 plus ion has shortest wavelength among the given options. Okay, students. Let's go for next question. See Heisenberg uncertainty principle. The uncertainty in the momentum of electron means delta p value they give. Uncertainty in the momentum delta p. How much they give ma? Delta p is equals to 10 to the power of minus 5 kg meter second inverse. Delta p value they give. So what we have to find out? Uncertainty in the position. Delta x value we need to calculate. Uncertainty in the position we need to calculate. H is equals to Planck constant is equals to 6.62 into 10 to the power of minus 34 joule second. Joule second is nothing but kg meter square second inverse. Kg meter square second inverse. So what is the related formula? Heisenberg uncertainty formula is delta x into delta p is equal to h by 4 pi is equal to h by 4 pi. From this what we have to calculate? Delta x we need to calculate. Delta x is equal to h by 4 pi into delta p. So h value have to substitute, pi is equal to 3.14 and delta p value have to substitute, then we'll get answer. Then h is equal to 6.62 into 10 to the power of minus 34 by 4 into pi value is 3.14. Pi means 22 by 7 is nothing but 3.14 into delta p value is 10 to the power of minus 5. 10 to the power of minus 5. Then the uncertainty in the position, if on simplification, just 10 to the power of minus 5 goes to upside, means it becomes positive. Means 10 to the power of minus 34 into 10 to the power of 5 becomes 10 to the power of minus 29. 6.62 by 4 into 3.14. On simplification, we'll get approximately 5.2 into 10 to the power of minus 30 meters. 10 to the power of minus 30 meters. So where that answer is present ma? 10 to the power of 5.2 into 5.27 into 10 to the power of minus 30 approximate, means first option is correct. Okay students, let's see the next question. 15th. Two particles A and B are in motion. If the wavelength associated with two particles, with particle A, lambda A they give. Lambda A is equals to 5 into 10 to the power of minus 8 meters. Calculate the wavelength associated with the particle B. Then the momentum, B particle momentum is half of A. Then they are asked what is the lambda B, we need to calculate. The wavelength of B we need to calculate. According to this, how to solve this question ma? According to de Broglie's wavelength, lambda is equals to h by P. Lambda is equals to H by P. Okay. Now, for this, lambda A is equals to H by PA. H by PA means H by PA means momentum of A, and lambda B, and we know that PB, momentum of B is equals to half of A. Momentum of B is equals to half of A means PA by 2. PA by 2. So according to that, lambda B is equals to H by PB. From this, lambda B is equals to H by PB value is PA by 2. PA by 2. Therefore, lambda B is equals to 2 into H by PA. What is PA value? H by PA value they gave in the question. That is nothing but lambda A. So the relation is lambda B is equals to 2 into lambda A. 2 into lambda A. 2 into lambda A value is 5 into 10 to the power of minus 8. Is nothing but 5 to the 10. 10 into 10 to the power of minus 8 means 10 to the power of minus 7 meters. So the answer is third option. The answer is third option. So indirectly, the momentum of B is half of the momentum of A. According to that, the wavelength of B is equal to 2 times of the wavelength of A. That is the important relation according to that momentum. So this is important relation, and lambda A value they gave. Then immediately we can calculate lambda B. Okay, ma. Okay, dear students, listen. First, lambda A value they gave. What is the relation between lambda A and lambda B? Lambda B is equals to 2 times of lambda A, because the wavelength, lambda is inversely proportional to momentum, and lambda B means which having more p value, it has lower lambda. So the p value of lambda B is half of the lambda A. That's why lambda B is equal to 2 times of lambda A. 2 times of lambda A. The answer is 2 into 10 to the power, 10 to the power of the answer is 10 to the power of minus 7. Third option is correct. Okay, students, let's see next. Next question. 16th question. The related to quantum numbers or quantum mechanics of atom. It's very easy, ma. The maximum number of electrons present in a subcell. L is equal to 3, N is equal to 4. If N is equal to 4 and L is equal to 3, L is equal to 3 means that is 4F subcell. 4F subcell. So maximum number of electrons present in a subcell. Maximum number of electrons in a subcell. Formula what I said, 2 into 2L plus 1. 2 into 2L plus 1. Already that formula we discussed. What is the meaning of 2 into 2L plus 1? 2 into 12 plus 1 is nothing but it indicates that number of orbitals. So in 4f subcell, how many orbitals are present? 7 orbitals are present. Otherwise, L value you have to substitute. Then Nishchal, very good. 2 into 3 plus 1 is nothing but 2 into 7 is nothing but 14 electrons. It's very easy. Okay, students. The same way for any subcell, maximum number of electrons in a subcell is equal to 2 into 2l plus 1 is nothing but 4l plus 2. 4l plus 2. Okay. Let's go for next question. 17th question. Let's see the total number of subcells in fourth energy level in an atom. Okay. Number of subcells in fourth energy level. N is equals to 4. So, number of subcells in a cell. What is the formula? The total number of subcells. Number of subcells in a cell is equal to n. So here n value is 4 means therefore and n is equal to 4. Therefore number of subcells in fourth cell is equal to 4. What are those 4 subcells? That is 4s, 4p, 4d and 4f. So these are the 4 important subcells present in fourth energy level or present in fourth cell. Yes, ma, Abjal, very good. 4. Let's see. 18th question is very, very important, ma. Which of the following set of 4 quantum numbers for an electron will has highest energy? What I said? Energy which has more n plus l value. N plus l value which has more energy. See here n plus l values you have to calculate. Yes, n plus l value is equal to here 5 and n plus l value is here 6. Here n plus l value is equal to 5. Here n plus l value is equal to 5. So second option is correct. Second option is correct. N plus L, 4 plus 2 is equal to 6 means second option is correct. Yes, ma'am. Okay, let's go for next questions. 19th question. Let's see an element, transition element X electronic configuration is in +3 oxidation state. Means X plus 3 electronic configuration is equal to argon 3d4. Argon 3d4 means here how many electrons are present? Argon has 18 electrons and 4 means X3 plus has 18 plus 4 is equal to 22 electrons are present. So how many number of electrons? Its atomic number we need to calculate. Atomic number is equals to number of electrons in neutral atom. So regarding that electrons, how to calculate atomic number? For neutral atoms, number of electrons is equal to atomic number. But X3 plus has 22 electrons. Then what is the meaning for X3 plus? Means X loss 3 electrons. Above 19, atomic number, how it is becomes 19? For example, Na plus is 10 electrons. Na, sodium, has 11 electrons. So whenever positive charge is present, the positive charge is present means what it indicates? It loss of electrons. See, X, the number of electrons in X is equal to 22 plus charge. 22 plus charge means 22 plus 3 is equal to 25 electrons. See, X has 25 electrons, X3 plus has 22 electrons. So, is equal to 25 electrons. Means Z is equal to 25. That is manganese. Z is equal to 25 means manganese. Third option is correct. It is Mn, manganese. Z is equal to 26 means iron. But not it is iron. X3 plus has 22 electrons, X has 25 electrons. Then X is equal to 25 means Abjal. Here the main important concept is what we have to remember when an atom has positive charge plus unit positive. For example, an atom has a positive charge is present means it loss of electrons. When compared to the neutral atom, positive ions has less number of electrons. For example, oxygen. Oxygen is present. The oxygen has 8 electrons. O minus 2 has how many electrons? 8 plus 2 is equal to 10 electrons. For example, O plus 2 has how many electrons? 8 minus 2 is equal to 6 electrons. See, O plus 2 has 6 electrons, then O is equal to how many electrons? Means O plus 2 means oxygen lost 2 electrons. Then automatically oxygen has 6 plus 2 electrons. 6 plus 2 electrons means 8. So whenever atom having positive charge means it has less number of electrons when compared to its neutral atom. So how many electrons it is less? What is the charge present? That many electrons it is less. So how much charge is present in X? Plus 3 units charge is present. Means it has 3 electrons less when compared to neutral atom. So X3 plus has 22 electrons. X has 22 plus 3, 25 electrons. Understood? Abjal, clear? Inform immediately. The remaining also understood, ma? Shravana, Rani, Aditi. Just a small concept, just what you have to keep it in your mind. Whenever positive charges are present, then how much positive charge is present, that many electrons are less for neutral atom. How much negative charge is present, that many electrons more present in negative ion. So in that case, the neutral atom, how many electrons are present? The negative ion containing electrons minus of its negative charge. Okay, then automatically number of electrons present in neutral atom will comes. Okay, let's see next. '25. Here, paramagnetic nature. Among the following, which is paramagnetic? Which is not paramagnetic? Not paramagnetic or paramagnetic means the atoms or ions which have unpaired electrons. Unpaired electrons. Unpaired electrons present. It is paramagnetic. All electrons are paired. All electrons are paired means unpaired electrons are absent. Then it is called diamagnetic. Is not paramagnetic means it belongs to diamagnetic. Among the following, which is diamagnetic, there are. Let's see the first one. Neon plus 2. Neon. Helium, neon. Helium, neon means what it is? Neon has 10 electrons. Neon 2 plus has 10 minus 2. is equal to 8 electrons are present. How the 8 electrons are distributed? 1s2, 2s2, 2p, 1s2, 2s2, 2p, 4, 2p4. So in the first 1s completely electrons are paired. So inner cells are completely paired. 2s also paired, but 2p, 4 electrons are present. According to Hund's rule, 1 will be filled. Then the first orbital will completely filled. But n is equal to 2. Number of unpaired electrons is equal to 2. It is paramagnetic. Now second option C, Be plus. Beryllium has how many electrons, ma? Beryllium has 4 electrons are present. And Be plus is 4 minus 1 is equal to 3 electrons. Its electronic configuration is 1s2, 2s1. 1s2, 2s1 means 1s is completely paired, inner cell. But 2s is there is one single electron is present, then n is equal to 1, means it is paramagnetic. Let's see third option, Cl minus. Chlorine has 17 electrons present. Cl minus has means 17 plus 1 is equal to 18 electrons are present. 18 electrons means argon configuration. 1s2, 2s2, 2p6, 3s2, 3p6. Completely filled. Means n is equal to 0. Hence it is diamagnetic. So Cl minus is not paramagnetic. In the same way, As3 plus, As plus. As means nitrogen, phosphorus, arsenic. Arsenic Z is equal to 33 electrons. So As plus means 32 electrons are present. This 32 electrons you have to distribute. Then what is the electronic configuration for 32 electrons? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p2. See, this all 1s2. 1s is completely filled, 2s, 2p, 3s, 3p, 4s, 3d. Up to here it is completely filled. 4p2. 4p2 means here 4p subcell has 3 orbitals are present, but they contains 2 electrons. According to Hund's rule, they are filled 1 electron. First orbit contains 1 electron, second orbit also contains 1 electron. Means n is equal to 2. Then it is paramagnetic. Okay, among the following, which is not paramagnetic means Cl minus. So paramagnetic or diamagnetic, how to identify, ma? Based on its electronic configuration. In that electronic configuration, the outermost shell or last shells, they contains unpaired electrons. Then it is belongs to paramagnetic. All electrons are paired, it belongs to diamagnetic. So Cl minus is diamagnetic. Okay. Next, isoelectronic species. What is the meaning for isoelectronic species? Isoelectronic species means the atoms or ions contain same number of electrons. Same number of electrons required. Let's see the first one, CO. CO. Carbon has 6 electrons, oxygen has 8 electrons, 6 plus 8 is 14 electrons. And Cn minus, carbon 6, nitrogen 7, and 1 unit negative charge is present means 1 electron extra came, is equal to 14 electrons. Next, NO plus, 1 unit positive charge is present means they lost 1 electron. Nitrogen 7, oxygen 8, minus 1 is equal to 14 electrons. Next, one more is C2, 2 minus. 2 carbon atoms are present. 2 into 6 plus 2 means 12 plus 2, 14 electrons. C, CO, Cn minus, NO plus, C2, 2 minus, all contain same number of electrons. That is 14 electrons present. That's why these pairs, this option is means CO, Cn minus, NO plus, C2, 2 minus, all are called isoelectronic species. In the same way, remaining options also you have to count that electrons. Then they are not all are in the not same electrons. That's why they are not belongs to isoelectronic species. So isoelectronic species means the main important thing is the given atoms or ions contain same number